Okay, so we're doing our physics test review. And just waiting for people to come in, and if nobody does, then I will just talk about some stuff and you guys can watch the video later. Let's see. Okay, just checking to make sure everything's working. Okay, just checking to make sure everything's working. So if you click the little box down here in this area-ish, it's going to let you put questions in, and then I can see your questions and answer them. So that's a good thing. So yeah, whenever you're ready, or if not, I'll just start talking about stuff that I think is important, and we'll go from there. Let me get out your review sheet to look at. Okay. So, just looking at this review sheet, standard stuff that we've done. Ooh, That's a good one. Okay, so I'll talk a little bit about, oh, I lost my one viewer, that's sad. Okay, I'm going to talk a little bit about position and time and acceleration and velocity and those things, and then I'll do a little bit of free fall, and then that will be it, unless some people come in and start asking me things. So here we go. So the first thing we want to talk about is position. So it all starts out with us wanting to know where things are. So if I'm standing here, well, I can do better than that, right? Here's me. Wow, that's an awful face. It takes me a minute to get used to writing on this tablet to do really good smiley faces, but I think I'm getting there. Okay, so here's me, right? I am at what we'll call position 0, or the origin. So I, of course, am interested in knowing where other things are. So, for instance, if there was a ice cream stand, then I'd probably want to know where the ice cream stand was relative to me so I could go and get some delicious ice cream. So the position, my position is 0, so that's me. The ice cream stand, maybe its position is 10 meters to the right. So if I wanted to find position for me, that's going to be 0. Position for ice cream, very important. That's going to be 10 meters. And we'll call that the positive direction, so I'll say it's plus 10 just to be specific. So remember, we're using the letter S for position. That's what you'll see most of the time when you are doing a college level class. Either they use S or X or R. They don't usually use D. When you start doing calculus, there's a lot of D's floating around, so they don't want that. So the change in position, we call that displacement. So if I left position 0 where I started, and I walked over to the ice cream stand, then we can find my displacement. So displacement, need something to write on. Hold on just a moment. But displacement we know is the change in position, so I would just be taking the final position, which is the position of the ice cream stand, so 10 meters, and subtracting my initial position, which is where I started, 0 meters, and that would be my displacement. So for displacement, we write a delta S, and it is the final minus the initial position. So in this case, that would be, the delta S for me would be 10 meters minus 0 for a displacement of 10 meters in the positive direction. We usually don't write that plus sign, but I'm going to do it just to be explicit, that I'm moving 10 meters to the right. And that's important because displacement and position are both vectors. Right? So if I'm standing here, and you tell me, let's say I'm blindfolded, and you tell me there's an ice cream stand that's 10 meters away from me, well, that doesn't really do me much good if I don't know what direction to go. So you've got to tell people where things are. It's very important. So position is a vector. You need a magnitude, that's the number part, that's the 10 meters, and you need a direction. So the direction is to the right. So the ice cream stand's position is 10 meters to the right, or 10 meters in the positive direction, however you want to phrase it, from the origin 0. And then for me, my displacement is a change from there to there, from 0 to 10. Now, it's possible that somebody else was standing here. They were closer to the ice cream than me, which is unfortunate. So maybe they were at 4 meters. So they're at 4, the ice cream's at 10, so that'll be for me. And the change in position for the lucky person that walks from 4 meters to 10 meters is just going to be 10 minus 4 for a change of meters there. For a change of 6, so his displacement is positive 6. He moves 6 meters to the right. So again, there's magnitude, 6 meters, there's direction. We know we're talking about going to the right. There could be somebody else even over on this side. So we'll put somebody else right here and say they're at 13 meters. So for that person, they're even luckier. So they're the even luckier person. And they started out at 13 and they went to 10. So the final position was 10. The initial position was positive 13. So we're going to subtract that. And we get a negative 3 meters for the displacement. So his change in position was from 13 to 10, so he moved 3 in the negative direction. So if you're moving to the right, we're saying that's positive, to the left is negative. So he moved 3 meters in the negative direction, negative 3 meters is his displacement. Still just talking to myself, but that's okay, I'm not going to get discouraged. Okay, so moving on, that is displacement. Now we also have velocity. So I can actually, hold on. Yeah, I guess I can just copy the whole page like this. Cool. So the really nice thing with the software, and I'm really looking forward to getting my board fixed so I can use it in class, is that I can copy and paste whole pages, and then I go back and the original page is still there. So, all right, that was page 1. Okay, so the original stuff is still back on the other page, so I can make some changes here. Okay, seems good. So besides displacement, we also want to know about velocity. So your velocity is how quickly your position is changing. So the velocity on average is just how much you changed in a certain amount of time. So whatever your change position was, divided by how quickly you made that change, that will tell you your velocity. Sorry, my software is being strange. Yes, okay. Since if it took me, and we know that my displacement, again, was 10 meters in the positive direction, plus 10, we'll say plus just to be really specific. So let's say it took me 4 seconds to walk to the ice cream stand. So that means that my average velocity would have been delta S over t, that's 10 meters in the positive direction divided by 4 seconds. So that gives me a velocity of positive 2.5 meters per second. So on average, every second, I move 2.5 meters to the right. So after 1 second, I would have been 2.5 meters away from 0, 5 meters after 2 seconds, and so on. Now, you remember from the bus driver lab that we talked about, that average velocity doesn't tell you what the instantaneous velocity was at any point, but it lets you know what the average was, and a lot of times that's all you need to know. So that's the basics of velocity. Now, we have those more complicated equations dealing with acceleration and all those other things, but a lot of times you just need this really basic relationship. So the change in position over time is the velocity. So don't be afraid to just use that if that's the situation presented to you. And if the velocity is constant, then, excuse me, I'm hiccuping, you can always use this. Now, for the person that was to the right, they have a negative velocity. So for that person, this person over here, their change was negative 3 meters, and maybe they did that in, let's say, 2 seconds. So their velocity, on average, was negative 3 over 2. So their velocity was negative 1.5 meters per second. So it's negative because they're moving in the negative direction. And so that's a very simple view of velocity. Okay. So sorry, my stuff doesn't, like, you can see my screen changing, but I don't see it changing, and so it's very weird, and I have to, like, toggle windows back and forth in order to see the new screen. So there we go, here's a new page. Okay, so that's velocity, and that's how you find the average velocity. If the velocity is constant, then you know that the change in position will just be the velocity times the time. So that's if you have constant velocity. Now, if the velocity is not constant, we have acceleration. And we know that the acceleration, or at least the average acceleration, is going to be VF minus VI divided by the amount of time it takes for that velocity to change. You could also say it's the change in velocity over time. Remember, the triangle means the change in. So if an airplane starts out going at a speed of, let's say, 150 meters per second, going this way, and it speeds up, and let's say that 10 seconds later, it's moving at 175 meters per second. And again, we'll say that the positive, that the positive direction is to the right. So this way is going to be, so this way will be positive. So our change in velocity, we had the final velocity was 175 meters per second in the positive direction. The initial was 150 meters per second in the positive direction. And we divide that by the time that it took. So I said it was 10 seconds later. So this would be time 0. This would be time 10 over here. So it took 10 seconds for that to happen. So we had an acceleration of 25 meters per second divided by 10 seconds to give us 2.5 meters per second squared of acceleration. This is getting really frustrating, I'm sorry. Like I said, you can see everything fine. It shows you exactly what's happening, but in the process of doing that, it keeps it for me a lot of the time. I can't see how things have changed. Okay, so anyhow, if another amount of time later, so let's say that at time equals 15 seconds, maybe we had to slow down. Right, so our plane is now, it's slowed down a lot, let's say, and now that the speed is just 100 meters per second. So maybe it's sped up to go over a hill or a mountain, and now it's slowing down to come in for a landing. So it's slowed down to 100 meters per second, and it took 5 seconds. So in that case, the acceleration, the final was 100. The initial was 175, and it took 5 seconds. So that gives us negative 75 meters per second divided by 5 seconds. So that's negative 15 meters per second squared. So this time the acceleration was in the negative direction. Our velocity changed, and it changed to the left. So from 0 to 10 seconds, we were going with a speed that was more to the right. So we were going to the right at 150, and now we're going to the right at 175, so we got even more to the right. So we're going to the right even faster. But if we went from going to the right at 175 to going to the right at only 100, then our velocity actually moved closer to, or moved in the direction of the negative velocity. So the acceleration was actually this way. So even though our velocity was forward, our acceleration was backwards. That made us slow down. So that is the idea behind acceleration, whether it's positive or negative. Okay, so we learned that we can work these equations around and get some useful tools from them. So the equations that we learned how to use. Sorry. Okay. So we ended up with VF is equal to VI plus the acceleration times the time. We ended up with the change in position is equal to the average velocity times the time. We already talked about that. And one way to find the average velocity is to take 1/2 the initial plus the final, and that is the average velocity, and then we multiply it by the time. So just like you would average together 2 test grades, we do the 2 velocities added together, multiply by 1/2. And remember, all of these are for constant acceleration only. Later on, we'll learn ways that you can deal with problems when there isn't constant acceleration. But for right now, we only really look at problems where the acceleration is constant. Okay. So we also had delta S is equal to VI T plus 1/2 A T squared, and there was VF squared minus VI squared is equal to 2 A delta S. So with these equations, there's 5 variables. There's the initial velocity, the final velocity, the acceleration, the time, and the change in position. So if I give you any 3 of those, you can find an equation that will let you find one of the other 2. So if I tell you initial velocity, final velocity, and acceleration, there's an equation you can use to find time. There's an equation you can use to find displacement. So any 3 variables, you can always find the other 2. So the trick is being able to pick them out of problems, and we've been practicing that a lot. So hopefully everybody's getting good at that, and you'll have more time to practice with it tomorrow as well. All right, so the last thing is free fall. So when something's in free fall, it's a constant acceleration problem, and we know that the acceleration is going to be the acceleration of gravity, and we know that it's going to be going down. So the acceleration will be negative g. A few other things we know about free fall is that it is symmetric about the peak. So free fall looks something like this. If this is time, and this is your height. So we'll call this, I'll just call it y for your height. So at the peak here, we know the velocity is 0, because it's changing from going up to going down. So if it changes from positive to negative, it has to be 0 somewhere. So the velocity of the peak is 0, always. So whenever you do a free fall problem, you know the acceleration is negative g, you know the velocity of the peak is 0. And that gives you 2 pieces of information that you can use. The velocity of the peak, that can be either the initial velocity or the final velocity. It's up to you and how you're approaching the problem. If I told you that something rose to a height of 35 meters and asked you how long it was in the air, you could try to figure out how long it would take for something to get up to here. Find the initial velocity, and you could work it out. But the easiest way to do it would be to say, well, this is going to be the initial point. I'm going to start here and just look and see how long it took to fall. Because we know the time that it takes to rise and the time that it takes to fall are the same. So there's half the time on the way up and half the time on the way down. We had a few equations that we worked out. Since we know that a is negative g and the velocity of the peak is 0, if you want to find the time it takes to get to the peak, you can use this equation here, and you just rearrange it a little bit, and you get the initial velocity over g, the acceleration of gravity. So that's a good equation to know. We also had, and if you want the total time, again, that's just going to be 2 times the time it takes for it to get to the peak, or 2 times the time that it takes for it to fall, either way. Okay, so the height of the peak, you know the final velocity in that case, so the velocity of the peak would be 0, the initial velocity would be whatever you threw it with to start, and then you know that a is negative g, so you can use this equation. And when you substitute things in, you find that the height of the peak is equal to vi squared over 2g. And that can be a helpful equation to know also. But the trick to doing any of these free fall problems is just to realize that the acceleration is always negative g, so you always know the acceleration, and the velocity of the peak is 0, so you always know either the initial velocity or the final velocity, as long as you start or stop at the peak. Right? So you can cut the problem in half, just find out what happens between here and here, or between the peak and back down here. And remember, when we say, so for the falling part, we might say how fast is it going when it hits the ground, how fast is something going when it hits the ground. So when we say when it hits the ground, we really mean that instant right before it hits the ground. So that's what we're talking about. Oh, I've got one person watching. That's awesome. I've just been talking to myself for a while. But there should be a button down in the bottom left of this video, and if you click that, it'll let you ask questions. So if you have any particular questions, I can try to answer those for you. But other than that, I'm just going to draw some graphs, and then that will be it. Oh, and that person's gone. Unfortunate. Okay, so another nice thing about the software, I've got all my handy lines and things, so you don't have to deal with my bad drawing, except sometimes I make them the wrong color. There we go. Nice axes, look at these. Wow. Okay. So let's start out with a position time graph. So for the position, I'm going to call the position X. So we'll say it's something moving along the X-axis, back and forth, forward and back. And this will be time. So grab some tools here. Okay, so let's say it starts out flat, it goes down, and then we'll go flat again. And then we can bring it back up. Let's make it really steep like that. Okay. So the questions that you can answer from this are, well, what's the position? This is a position time graph, so here I'll put some numbers on it. Let's call this 5 meters. Let's call this -4 meters. And it's going to be 1, 2, 3, 4, 5 seconds, 6, 7, 8, 9, 10, 11, and 12. So 10 seconds here. Okay, so we can look and we can pick out the position. So you can see that from 0 to about 3. Right, so from 0 to about 3, our position is 5 meters, and it's not changing. Then we start changing, and you can pick out the value off the graph at any given time and make an estimate of what the value is. And then down here, between about, it looks like 6.5 seconds, and up until about 11 seconds, we're staying at -4 meters. So we started with, we usually say right is positive, so we started to the right, 5 meters to the right of the origin. We moved back towards the origin, back towards 0 of our coordinate system. Then we moved past 0, and we kept going, and we got to -4. We stayed there for a while, and then we started moving to the right again, quickly, because this is steep. Right? And then we very quickly got back to the origin, and then moved past it, and moved back up to 5. Or just about 5, anyways. So that can tell you the position just by looking at what the graph says. And then if you look at the slope of the graph, that tells you about the velocity. So the slope of a position time graph is the velocity. So here you can see that the slope is negative. So that tells you the velocity is negative. That tells you that you're moving towards the negative numbers, or towards more negative numbers. So we started at 5, and then we started moving to the left. Right, we're getting closer and closer to 0. That's a negative velocity. Now over here, you've got a positive velocity. Even though the numbers are negative, we're moving in the positive direction. So we're moving to the right. We're going from -4 to 0. That's movement to the right. And then we're moving past 0, we're moving to positive numbers. Again, that's still movement to the right. So the slope is positive, that's a positive velocity. One thing not to get caught on, even though it crosses the axis and the position is 0, that doesn't mean the velocity is 0. If your position was 0 and your velocity was 0, you wouldn't go anywhere. You would just stay there. So we have this velocity, it's the slope of this line. Just because you cross the axis doesn't mean anything special about the velocity. It is still whatever it was right before you got there and whatever it was right after you were there. It's always, it's just going to be the same. Okay, we also have velocity time graphs. So here I'll just get rid of the annotations and we'll write a velocity time graph. Cool. So I'm going 5 meters per second for a while, put -4 down here. Okay, so again, you just read velocities, right? So I'm going 5 meters per second, I'm moving to the right. Right? So this whole time I'm moving to the right. Then my velocity starts to change. The slope of this graph is the acceleration. So slope is negative. Then the acceleration is negative. Now, just because the acceleration is negative, that doesn't mean the velocity is. So a lot of people, when they see the slope going down, they say, oh, you're moving to the left now, but you're not. Anytime you're above the axis, these are all positive values. I'm moving at 5 meters per second to the right. Now I'm moving at 4 meters per second to the right, 3 meters per second to the right, 2, 1, and then finally I'm going to reach 0, and I stop moving for just an instant. Now the graph passes into negative numbers, and now I'm moving to the left at a speed of 1 meter per second, a speed of 2 meters per second, a speed of 3 meters per second, and finally a speed of 4 meters per second, and I'm going to the left, so it's -4. -1 meter per second, -2, -3, -4. So the slope is negative that whole time. The acceleration is negative that whole time. But for a significant part of that time, I'm moving in the positive direction. So you don't want to say that the velocity is negative just because the slope of the velocity graph is negative. Right, same thing over here. Velocities are negative, but the slope is positive. So that doesn't mean we're moving in the positive direction. It just means the velocity is changing in the positive direction. So I was going -4, I'm starting to slow down. Now I'm going -3, -2, -1. I stop just for an instant, and then I start moving to the right. And I'm speeding up. Okay, so here, positive velocity, right? Negative acceleration, that means I'm slowing down. Over here, negative velocity, negative acceleration, I'm speeding up. Negative velocity and positive acceleration, I'm slowing down. And then over here, it's positive and positive, so I'm speeding up. So if the signs match, you're going faster. If they don't, you're going slower. Okay, well, if nobody has any questions, then that is going to be it for this review. The video will stay up so you can watch it. Hopefully that helps. You can always email me with questions, and you'll spend tomorrow looking at the review. You can go over the other review things that we've been doing. So you've got those free fall problems. You've got all the kinematics, constant acceleration questions that we looked at today. So keep practicing those things and get ready for the test on Friday. All right, good luck, everybody. I will see you on Friday.